right, let me blow this up so that I can write on it and minimize that. All of a sudden I got hit by an allergy attack. All right, so what does 4 factorial mean?
4 times 3 times 2 times 1.
So what's the value of that?
24.
Second one. 6 choose 4. So what's that? First of all, what does N choose R mean?
It means like it means like 4 out of 6.
Well, it means N factorial.
Oh, you mean like the formula?
Divided by, yeah, because what we're going to do is substitute the two numbers that we have.
Oh, okay.
So that's what N choose R means. So if we're going to do 6 choose 4, then it's going to be 6 factorial divided by 2 factorial times 4 factorial. What's that equal to?
It's equal to 6 choose 4. Or do you want the actual answer?
Uh-huh. It's not that hard. Watch how you do it. That's 6 times 4 times 3 times 2. This is 2 times 4 times 3 times 2. Those cancel, so what it is 30 divided by 2. 15.
Uh-huh.
That's what that is 15.
Uh-huh.
All right, let's look at the next one.
Okay.
Yeah, you must show your work, not just an answer. And the reason she says that is because you can get an answer out of your calculator.
Yeah.
6 choose 4. Yeah, your calculator will tell you that's 15.
Okay.
Number 3. How am I going to set that up? I'll give you a hint. It's a combination problem.
So is choose for permutations? I forgot.
No, there's two types of problems. There's permutations and combinations. Here, let's go over them.
Yeah.
N pick R is just n factorial over n minus r factorial. N choose R is n factorial over n minus r factorial times r factorial. So that's the difference between the two.
Uh-huh.
Not much of a difference, but it's significant. Okay? And number 3, the reason you use choose instead of pick
is because the order doesn't matter.
The order doesn't matter.
Yeah.
They're saying that, here, how many ways can you sort the first 3 items out of a collection of 10 items? I think that's a choose situation.
Yeah.
Because you don't care what 3 items, the order they're in.
So would it be 10 choose 3?
Yeah,
Yeah.
exactly. 10 choose 3. Which is what?
10, 10 factorial over 10 factorial minus 3. Wait. No, wait. It's 10 factorial over 7 factorial?
Well, here's what it is. N choose R is n factorial over n minus r factorial times r factorial. Here's the way
Yeah,
I
I know.
remember that. There's two n's and there's two r's.
Uh-huh.
So it starts out just like a permutation, n factorial over n minus r factorial. But there's another term in the denominator when you're choosing, and that's that extra r factorial. So it's 10 factorial over n minus r factorial, which is 7 factorial, times 3 factorial. Now, the way to do this is the 7 factorial cancels everything but the 10 times the 9 times the 8.
Uh-huh.
That's divided by 3 factorial, which is 3 times 2.
Uh-huh.
So it's really 10 times 9 times 8 all over 6. What is that? 80 times 3 halves, that's 120. So that's how many ways.
Okay.
You can sort 3 items out of a collection of 10 items.
Mm-hmm.
These permutation combination problems can be tough.
Uh-huh.
They can definitely be tough. Go through them one at a time here.
Okay.
Yeah, I'll help as much as I can. This is not my strong suit, I will tell you that. But I think I can figure it out. Okay.
So it's basically how many ways can you order 8 different players?
Well, got to arrange his 8 starting players into a lineup. I presume what that means is his pitcher's batting ninth always. So how many ways can his 8 players bat first?
What?
How
What
many
did you say?
different ways can you come up with a player out of 8 who will bat first?
8.
Okay.
Oh, it's 8
Once that
factorial.
player is chosen, how many ways can a player bat second?
7, 6. Yeah, it's 8 factorial, right? Or does it just go to... Yeah.
That's your
Okay.
okay. Now they start getting hard. Let me see if I can understand them first.
So there's only 2 ways?
That's right. In other words, he's got player A. Let's say he's got player A and player B, and he wants to play second base and shortstop. Well, he can either have A playing shortstop and B playing second base, or vice versa. That's it.
Uh-huh.
So there's 2 ways.
Okay, so number 6 then. Then he could make... There's 2. There's... Is it 8 factorial times 2 to get this?
Let me think about this one for a second.
Okay.
Let's, so he's really only got 6 other players to play the other 6 positions, right?
Huh?
In other words, if he's got player A and player B that he knows he wants to play at second base and shortstop, then he's
Yeah.
got 6 other players to play the other 6 positions.
Yeah.
So that's 6 factorial.
So it's 8 factorial plus 6 factorial?
Not plus, it's 6 factorial is the number of ways the other 6 players can play all the positions except shortstop and second base. And there's, for each of those, there are 2 ways. So it's 2 times 6 factorial.
So this is just for when they're in the outfield?
What's that?
But it's combining both the batting order as
In other
well.
words, think of the problem as this. He's got 8 positions to fill with 8 players,
Yeah.
not counting pitcher.
Yeah.
And he knows he wants
2 of
2 of the
them
players to play shortstop and second base. So that leaves 6 other players to play the other 6 positions.
Uh-huh.
How many choices does he have at first base? 6.
6 and
At
5.
third base, 5. Left catcher, 4, so forth. So the number of ways for the other 6 positions is 6 factorial. And then for each of those ways, there are 2 ways for him to use those first 2 players at second and shortstop. So it's 2 times 6 factorial.
Okay, yeah. And then...
Now, I'm not sure why it said using your answers to the previous 2 questions.
Because you're supposed to combine it with the batting order as well.
Yeah, well, except it wasn't really a batting order. I misspoke when I said that. It was a positions. In other words, if we go back to question 4, when we're talking about lineup, we're talking about who plays first base, second base, shortstop, and so forth. The 8 position players. Well, that's 8 factorial. But if the guy already knows that he wants 2 players playing 2 of those positions, well, then there's really only 6 other players. So I'm not sure why number 6 says use your answers to the previous 2 questions, because the answers were 8 factorial and 2. But it seems like the real answer to question number 6, well, maybe question 6 doesn't assume that he wants 2 players to play those 2 positions, but it has to. It's got to be 2 times 6 factorial. I'm not sure why. You don't have answers to these, do you?
No, I don't. Not on the...
That's too bad, because these kind of questions, you almost need answers just to verify that you're doing it right.
Uh-huh. Okay, we can skip it for now.
I believe 6 is 6 factorial times 2.
Okay. We can, if you want, we can skip these types of problems so we can get on to that.
Let's look at each one of them. A lot of them I can do.
Okay.
So what is this one, number 7, do you think?
It's a combination.
Yeah.
Right?
It's like, do you play cards?
Yeah.
If you have a flush, you don't care which, if you have a heart flush, you don't care which heart you got first.
No.
If you got a heart for, let's say you have an ace-high flush, well, you don't care if you got the ace of hearts first, second, third, fourth, or fifth. So the order does not matter. So this is a choose problem. And there are 52 cards, and you're wanting to choose 5.
Yeah.
So the answer to that is 52 factorial divided by 47 factorial times 5 factorial. Now that's a pretty big number. That's still 52 times 51 times 50 times 49 times 48, all divided by 5 times 4 times 3 times 2. That's a huge number. But as long as they said we could leave our answers like that, then that's your answer right there.
Okay.
Okay.
So, yeah, it's just the formula.
Yeah, well, and they said you can leave your answers in factorial. In other words, they don't need you to give them the number. That's like
unless they say to.
multiple millions of hands. Different ways you can get 5 cards out of a 52 card deck. How many ways can you rearrange the letters in the word Joseph?
6 factorial. Wait. Is it?
I think so. In other words, the
because there's no repeat.
letter can be 1 of 6. The second letter can then only be 1 of 5.
Yeah.
Yeah, so it ends up being 6 factorial. How many ways can you rearrange the letters in the word Bible?
A little. It's because since there's 2 B's and
right. So this is 5 factorial divided by 2 factorial, I believe. Trying to remember where in my book that formula is. I think I know where it is. There's a specific formula that I'm looking for. Hold on. Let me make sure I got it right. Well, I'm not looking in the right spot.
It looks right.
Let me think about this for a moment. Maybe I can figure it out. How many letters are there that can go in the first position?
1, 2, 4, yeah.
And in the second position? No, there's a specific formula that I really need. And I think what it is the number of letters in the numerator, 5 factorial, divided by the duplicates, basically. The 2b. Feel more comfortable if I was looking at it in the book, though. I'm not positive on that one. So maybe we should go on. I can't seem to find it in the book, so let's see how many of these I can do. Well, let's. How many ways? Well, there's 8 ways for first person to get an A. In other words, there's 8 different people that could get an A.
Uh-huh.
Not sure how to do this one, Dominic.
Really?
I just don't get enough students that get this deeply into combinatorics and permutations and probability. So I don't get these tough questions often enough to be expert in them. Now, on number 11,
Isn't that just add them all up since the order doesn't matter? And wait, no, because no, you have to factor in the colors that they are.
well, let's see. You have 13 total ties. So how many ways can I arrange my tie? In other words, I could have red, black, blue. I could have red, red, red. In other words, I've got 13 choices.
It's not 13 factorial, is it?
I don't think so. It's 13 choose. There's that many ways to arrange the red ties. I'm not sure about this, but it might be this. Like I said, I'm reluctant to even put myself out there as a tutor on this. In other words, there's this many ways to arrange your 3 red ties.
Uh-huh.
Plus, there's this many ways to arrange the 6 black ties, plus this many ways to arrange the 4 blue ties. Not positive if they should all be added or multiplied.
Okay.
I'm not even certain that if you sent me this in advance and gave me time to look at it, whether I'd be that much better off. I just don't do it that often.
Huh. Maybe I should tell my teacher.
Huh?
Maybe I should tell my teacher you should tone it down.
Well, no, you go to a private school, don't you?
Yeah, maybe.
That's the problem, is that most of my students are public school, Common Core students. So they touch on combinations and permutations, and they touch on probability, but that's about it. They don't get into it, unless they're taking a probability and statistics course, in which case I tell them that I don't do that, and they should find somebody else. Because that's about all my capabilities are, is touching upon it. And only if I have a little bit of advance notice where I can try to find examples and stuff. Well, let's see. Number 18 I might be able to figure out. I'm trying to think of some of these problems where I can at least give you a little bit of help on. So how can I finish filling out this table?
30 plus 2, and then you take the difference, like starting from get the total country listeners.
What's this spot right here need to be?
8. I'm guessing which spot. Yeah, that spot's 8.
Oh, I'm sorry. Okay, and then go across, get the total?
Yeah, so it's 30. And then
the top one, which has to be 40.
Yep.
And that one has to be 10.
And then
That one has to be 25. Means that one has to be 5. This one has to be 30 minus 7, 23. Now, they should all add up.
yeah.
And that's what you always want, is you want these three numbers here to add to that total, those three numbers to add to that total. You want the columns to add also to the total at the bottom.
Yeah. I'm good at these.
All right? Now, if you selected one student at random, what's the probability that they're an elementary student that prefers rock music?
1/10.
Okay. Are the events in elementary school and prefers rock music mutually exclusive? No, they're not.
No, yeah.
Mutually exclusive would mean that nobody in elementary school prefers rock music. But clearly 10 people do. What is mutually exclusive is the number of people in elementary school that prefer pop music. There are none of those. Okay? Are the events in elementary school and prefers rock music independence?
Elementary school, yeah. Wait, yeah.
Well, 10 out of 40 elementary school prefer rock music.
Yeah.
I am not sure about this one. I would say the number of people in elementary school is independent from the number of people in middle school, and that's independent from the number of people in high school. But I would say the people in elementary school and rock music prefers are not independent. They're dependent. There's 10 of them. I'm not real sure what they want on this one, to be honest.
I think my teacher said that it's dependent if they change the numbers, but they're independent if they don't.
Yeah, I wouldn't want to say. However, what's the probability that a student you know prefers pop music is in high school?
Can you show my row? Yeah.
Man, I erased what I had up there, but that's okay.
No, you're on your Google, I think.
Hold on a second. Well, I've got a program that takes a screenshot and allows me to draw on it, but then when I erase it to get back to the original, but that's okay. We can answer this question. What's the probability that they prefer pop music that they're in high school? Well, let's
It's
filling out the pop column. So this was 23. So what percentage of the people that prefer pop music are in high school?
12 of 30.
12 of 35.
Oh, there's 35.
Well, there's 35 total people that prefer pop music.
Oh.
And 12 of them are in high school. So if they're asking us, what's the probability that a student you know prefers pop music is in high school? So if we know a student prefers pop music, the odds are 12 over 35 in high school.
Yeah, I read it wrong. I read like, I thought they had to be in high school, and like they were asking for probably a different.
These are tricky, for sure. What's the probability a randomly selected student prefers country music or is in elementary school? Well, first of all, a randomly selected student that prefers country music is 40.
Out of 100. And elementary is also 40 out of 100.
Or means that.
So
Elementary is 40. That ended up being 40.
yeah.
So either or. Yeah, because there's, well, except there's, what did it say? The probability that they either like country music
Or
they're in elementary school. So that is the probability of A or B, which is, I believe, the probability of A plus the probability of B minus probability of A and B. And the probability of A and B, what was it? They got either like country music or are in elementary school?
Yeah.
Well, 30%. So it seems to me that it should be 40% plus 40% minus 30%. I would be tempted to say 50%.
Why is that?
No, now that I think about it, if I said to you, what's the probability that somebody is not in elementary school and does not like country music? Well, that's 70%, because there's 70. In other words, anybody that's not in that category. They're not, no, there's 40% not, so there's 60% not in elementary school.
Isn't it just 40%? Because like, oh.
No, hold on. This I can find. Let me make sure I get the right probability formula here. I think I can find it. When you have, yeah, it's probability, oh man, maybe this book I have that I'm trying to find this stuff in doesn't cover this enough. Conditional probability is close to what we're looking for. No, this book doesn't have what I'm looking for. I don't know why. Yeah, that's not going to do me any good. I'm not sure what book I had that had all the probability stuff in it. I think it was my Algebra 2 book, now that I think about it. But there's a formula for the probability of A or B if there's a dependency. Yeah, here, let me just look in my other book. I know it's got it. All right, I found the book stuff I was looking for. And additional probability. Yeah, it's exactly the way I wrote it. The probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So this was correct. 50%. because the probability of country is 40%. The probability of elementary school is 40%. And the probability of A and B, meaning both elementary school and country, is 30%. So it's 40 plus 40 minus 30. So 50% would be the odds that somebody would be either in elementary school or country music fan.
Okay.
Now, hold on one second. I might be able to find that other formula I was looking for, but I was looking in the wrong book. No, doesn't look like it. So let's go on.
Well,
Actually, it's 5 o'clock. Yeah, we're kind of out of time. So
okay.
I will let you go, and I will touch base with you again on Thursday.
Yep.
Can you do me a favor and send whatever material you're going through in advance? Give me at least an hour.
Sure.
Before your session, so that I can
yeah. I'll text you if I send you something.
Whatever. Yeah.
Yeah. Okay.
All right, Dominic. Nice.
Yep. Have a good one.
Have a good
nice
one.
To see you again.
Bye-bye.